Okay, question number 9. An analyst titrates acidified solution. So this is in acidic medium. Okay, containing 0.153 purified sodium oxalate with potassium permanganate. Purple endpoint reached. Okay, when the chemist had added 41.45 ml of potassium permanganate. Write balance half reaction for the oxidation of oxalate ion to carbon dioxide. So we know that oxalate ion undergo oxidation to form carbon dioxide. But look at question B. Write the balance net ion equation. So that means this is the overall equation lah. Balance overall equation. Okay. For the reaction between acidified CaMnO4 and Na2C2O4. So that means this oxalate ion undergo oxidation and our potassium permanganate undergo reduction. But MnO4 minus will be reduced into what ion? It's not given in the question. Why? Because it assumes that is your basic knowledge. Because as you know, there are two types of titration. There are two types of titration. The first one is what? First one is acid-base titration. So acid-base titration, we must add indicator. Why? Because both acid and base are colorless. So in order to know where should we stop the reaction, where is the end point, we must use indicator. Indicator is a substance that can that have different color in acidic and it also in basic condition. So we know where the end point is. The end point is the point where the indicator changes color. So we know that we have to stop the reaction. But for second titration, which is known as redox titration, redox titration means titration involving reduction and oxidation. Reduction and oxidation must occur at the same time. Simultaneously. So now usually redox titration, redox titration we don't use indicator. Why? Because the endpoint can be determined by using the oxidizing agent. Oxidizing agent is made up of transition element. Transition element, as we know, it have various oxidation number and also different color. So when this oxidizing agent undergo reduction, so we can see the changes in color. When it undergo reduction means the oxidation number decreases. So when the oxidation number decreases, the oxidation number of that element changes. So there is a color changes. So we know that is the end point. So commonly used oxidizing agent are what? The first one is potassium dichromate. The second one is potassium permanganate. Right? Potassium dichromate consists of chromium, which is a transition element, and potassium permanganate consists of manganese, which is also a transition element. So now, this dichromate ion going to reduce into Cr3 plus ion. So in this dichromate ion, the oxidation number for chromium is plus 6. So it's going to reduce to plus 3. So while dichromate ion is in positive 6 oxidation number, the color is orange and it will turn into green when it is being reduced. So now permanganate ion reduce into Mn2+. So the oxidation number for manganese in this permanganate ion is plus 7. So reduce into plus 2. So when the oxidation number of manganese is plus 7, it is colorless. Meanwhile, when it is in the oxidation number of plus 2, it will turn into purple. Therefore, we can read here, the purple endpoint is reached. That's mean at that time, reduction has completed. So now that's mean you need to know. Even though the question don't give you, so you must know these two commonly used oxidizing agent. So now we move on to question number 1. Okay, just balance the half equation for oxidation. Okay, so number 1. Okay, A. So for oxidation, okay, we know that auxiliary ion C2O4 minus, okay, become CO2. So the first one, you remember, you must balance EOHC. So the first one is balance element other than oxygen and hydrogen. So now we have carbon. On the left side, there are 2 more of carbon, so you have to times by 2. Next, we need to balance oxygen. So on the left side, there are 4 more oxygen and 4 more oxygen. So you don't have to balance anymore. And since there are no water added, so there are no hydrogen here. So the last thing we need to do is balance the charge. Okay, so now on the left side is negative 2, the right side is 0. So you must add electron to the more positive side. So between negative 2 and 0, it is 0 lah, is the more positive side. So how many electron do we have to add? We have to add 2 electron. Okay, so this is the answer for question A. So next for B, write the balanced net ion equation. So you already have the oxidation equation. So now that's mean you have to write the reduction. Okay, reduction involve permanganate ion MnO4 minus aqueous, okay, forming Mn2 plus. Okay, so now first balance element. Okay, 1 more of manganese on the left side and 1 more manganese on the right side. Next, you have to balance oxygen. So on the left side, we have 4 mole of oxygen. So that's mean you have to add 4 moles of water on the right side. And then on the right side, there are 8 mole of hydrogen. So you have to add 8 mole of H plus, right, on the left side. So next, balance the charge. So this is negative 1, positive 8, so overall charge equal to positive 7. Meanwhile, on the right side, this is positive 2, 0, so the overall charge is positive 2. So now, you need to add electron to the more positive side, which is positive 7. How many electron? Okay, just calculate the difference between these two. 7 minus 2 equal to 5, so that means you have to add 5 electron. Right, so this is the reduction equation, but it asks you to write the balance overall equation. So if we can see, number of mole of electron, okay, transferred in the oxidation reaction is 2, meanwhile for the reaction is 5. So that means you have to times by 5 for the oxidation and also times by 2 for the reduction equation. So now oxidation equal to, so that means you have to times by 5 times by 2. So 5 C2O4 2 minus aqueous plus 2 MnO4 minus aqueous plus 16 H plus aqueous. No, I'm sorry. So I'll just write the oxidation equation first. Okay, sorry. Will become 10 CO2 gas, 10 electron. So now then we are going to write the reduction equation. It will become 2 MnO4 minus aqueous plus 16 H plus aqueous plus 10 E produces 2 Mn2 plus aqueous plus 8 H2O. So now just cancel the electron. So your balance or your net overall equation will be 5 auxiliary ion react with 2 mole of permanganate ion plus 16 mole of H plus produces 10 mole of CO2 gas plus 2 mole of permanganate ion plus 8 mole of water. Okay, so you got this answer. Okay, please make sure you have this final answer. So for balancing equation, final answer, please make sure, okay, please make sure there have state Paste it in your answer.